Hello everyone. Today we are going to study the chapter Binomial Theorem. So first let us see what is the meaning of binomial. Binomial means an expression consisting of sum or difference of the two terms. So binomial means what? Binomial means we can write it as expression consisting of two terms. So two terms, either we can add or we can find the difference of two terms. So those terms we are going to call it as binomial. So examples for binomial are a plus b, a minus b, x plus 1, 1 minus x. These are the examples for binomial. See here, there are two terms and we have used the sign, either plus sign or minus sign. So any expression consisting of two terms with the addition sign or plus or minus sign, we are going to call it as binomial. So in your lower classes, we have seen the expansions of binomials like a plus b whole square, a plus b whole cube, so on. So if you recall those expansions, suppose consider a plus b power 0. So a plus b power 0 is 1 with the condition a plus b not equals to 0. If a plus b is equals to 0, what happens? 0 power 0. So that is indeterminate form. So a plus b power 0 is 1 with the condition a plus b not equals to 0. Next, a plus b power 1. So a plus b power 1 becomes a plus b. Next, a plus b whole square. So a plus b whole square, we can write it as a plus b into a plus b. So if you expand this one, what we are getting? A square plus 2ab plus b square. Similarly, a plus b whole cube. So a plus b whole cube means we can write it as a plus b whole square into a plus b. So a plus b whole square means this one, a square plus 2ab plus b square. If you multiply that with a plus b and if you simplify, so what we will get? A cube plus 3a square b plus 3ab square plus b cube. Similarly, if you find a plus b power 4, so a plus b power 4 means what we can write? A plus b whole cube into a plus b. So that is equals to a plus b whole cube means this expansion. If you multiply this expansion with a plus b, so what we will get? A power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b power 4. So these are the expansions of a plus b with the index 0, 1, 2, 3 and 4. Now we can see some of the observations in these expansions. So the first observation we can see is, so if you compare the index with the number of terms in the RHS, see here, index is 0, number of terms is 1. If index is 1, number of terms is 2. Here index is 2, number of terms is 3. Similarly here index is 4, number of terms is 5. So first observation is number of terms in the expansion is what? 1 more than the index. So this is the first observation, that is number of terms in the expansion, number of terms in the expansion is what? That is equals to 1 more than the index. Suppose if we consider the index as n, so number of terms in the expansion is what? N plus 1. So second observation is, so if you see here all these expansions, see powers of a is goes on decreases. See a power 1, here there is no a term, means we can consider a power 0 here. A square, next a power 1, next a power 0. A cube, a square, a power 0. A power 4, a cube, a square, a power 1, a power 0. So powers of a is goes on decreases by 1. So powers of a is what happening, it is decreasing by 1. And what about powers of b? See here there is no b term, so we can take it as b power 0 plus here b power 1, here b power 0, b power 1, b power 2, b power 0, b power 1, b power 2, b cube, here b power 0, b power 1, b square, b cube, b power 4. Means powers of b is increasing by 1. So this is the second observation. So one more observation we can see from these expansions is, if you take the sum of powers of a and b, so sum of powers of a and b is equals to the index. See here in this term a power is 1, b power is 0. If you add 1 plus 0, that is equals to 1. Here also a power 0, b power 1, 1 plus 0 becomes 1. Similarly here 2 plus 0, that is 2, 1 plus 1, 2, here 2 plus 0, 2. If you take any term in the expansion, if you add the powers of a and b, what you are getting? You are getting the index. So this is the third observation, that is sum of powers of a and b in any term of the expansion. In any term of the expansion is equals to how much? That is equals to index. So if you take n as index, so the value becomes n. So these are the observations we can see from these expansions. See here, suppose if I want to find the value of a plus b power 10. So if you do this method, so what we have to do? First we have to compute the value of a plus b power 9. Then we have to multiply that with a plus b. Then we will get the expansion of a plus b power 10. So this is very difficult method. So, and it is also difficult as well as lengthy procedure. So we are going to see how to find the expansions of a plus b for higher powers of n. So we have seen that for higher powers of a plus b, it is difficult to find the expansion. So let us see how to overcome that difficulty. Suppose if we consider the index as well as coefficients. So when index is 0, we have seen coefficient is how much? A plus b power 0 is 1. So coefficient is 1. When index is 1, a plus b power 1 means a plus b. So coefficients are how much? 1 and 1. So when index is 2, that is a plus b whole square. A plus b whole square means a square plus 2ab plus b square. So coefficients are 1, 2, 1. So similarly, when index is 3, a plus b whole cube. So that is a cube, that is coefficient is 1 plus 3a square b. Similarly, 3ab square plus b cube. When index is 4, so if you see the coefficients, what we are getting? 1, 4, 6, 4, 1. So if you see these coefficients, so we can arrive at some pattern. Okay, if you see the coefficients for different indexes, so by using these coefficients we can write the coefficient for next index. Suppose n is equals to 5, we can write the coefficients. How to write the coefficients? See here, if you check each row here, each row starts and ends with 1. So if you see any row for any index, so each row is starting with 1 as well as it is ending with 1. And other elements of row can be obtained by adding the coefficients of the previous row. Say here 2. 2 can be obtained by adding this 1 and 1. Similarly, 3 can be obtained by adding this 1 and 2. Similarly, this element 4. If you add these two elements, we will get 4. 6 means 3 plus 3 becomes 6. 4 means if you add these two, we will get 4. So like this, if you want to get the coefficients for index 5 means what we can write. Suppose consider, then if you consider the index 5, what are the coefficients? I can write it as, the coefficients will start and end with 1. And other elements can be obtained by adding the elements of the previous row. 1 plus 4 becomes 5. 6 plus 4, 10. 6 plus 4 becomes 10. 4 plus 1, 5. So like this we can obtain the coefficients for any index. So here also what happens? So this also very lengthy process. Suppose if I want to find the coefficients for the index n is equals to 10, again I have to write what? All the rows till n is equals to or index is equals to 10. How to overcome this difficulty? So let us see how we can overcome this difficulty. So also it looked like a triangle. If you consider this array of coefficients, so it looked like a what? It looked like a triangle. See here, this looked like a triangle. If you consider these elements, it looked like a triangle. So we are going to call it as Pascal's triangle. So it is known as Pascal's triangle. So why we are calling it as Pascal's triangle? Because Pascal is a French mathematician. Okay. So on his name, we are going to call this triangle as Pascal's triangle. So as I told, for higher powers of n, again writing this triangle for different indexes is difficult. So how to overcome this one? Let us see. So we have seen the combinations. So that is NCR. NCR means selecting R objects out of given n object is given by n factorial by R factorial into n minus R factorial. So this is the concept of combinations. Selecting R objects out of n objects can be obtained by n factorial by R factorial into n minus R factorial. So we can use these combinations to write the coefficients. See 1 here, 1 means what we can write? I can write 1 is same as 0, C, 0. Here index is 0. So the value of 0, C, 0 value becomes 1. See here 0 factorial by, again 0, C, 0 means 0 factorial by 0 factorial into 0 factorial. So 0 factorial is 1. So this 1 I can write it as 1C0. Again this 1 can be written as 1C1. This 1 I can write it as 2C0. 2 means 2C1. Here 1 means 2C2. If you want, we can verify the answer by taking suitable n and r. Similarly, this 1 I can write it as 3C0. So 3C1. So 3C2. This is 3C3. So similarly, this can be written as 4C0, 4C1, 4C2, 4C3, 4C4. So I hope you have understood how to get the coefficients for any index. 0 means what I will get? 0C0. 1 means 1C0, 1C1. 2 means 2C0, 2C1, 2C2. Similarly, suppose I have to find the coefficients for the index n is equals to 10. Means what I can write? I can get the coefficients as, see here, 10C0, 10C1, 10C2 till where 10C10. So this observation we can use to write the coefficients. Again we can see this is very interesting triangle, Pascal's triangle. We can obtain different patterns from this triangle. So let us see what are the different patterns we can obtain from this triangle. So one is, if you see each row, see here, this is 1 is there here. 1 means what I can write? I can write it as 11 power 0. 11 power 0 is 1. Here 1, 1 means 11 power 1. 11 power 1 becomes 11. Here 1, 2, 1. 1 to 1 means what I can write? 11 square. Here 1, 3, 3, 1. So means I can write it as 11 cube. Here 11 power 4, so on. Similarly, if you add the coefficients in each row here, if you see only one coefficient is there, that is 1. 1 means I can write it as 2 power 0. Here coefficients are, if you add the coefficients, 1 plus 1, 1 plus 1 means 2 power 1. Here 1 plus 2 plus 1, that is 4. I can write it as 2 square. Here how much? 6 plus 2, 8. That is 2 cube. Here 10, 14 plus 2, 16, 2 power 4. So if you add the coefficients in any row, it will be what? Power of 2. Suppose if you add the coefficients of nth row, so what you will get? You will get it as 2 power n. This is another interesting fact we can obtain from these Pascal triangles. Like this we can obtain many facts. See, if you consider these elements, so we will get natural numbers 1, 2, 3, 4, 5. Similarly, if you consider these elements, here also what we are getting? We are getting natural numbers 1, 2, 3, 4, 5. If you observe carefully this triangle consisting of these coefficients, so you can find out many interesting facts from this triangle. So now, by combining all the facts what we have studied till now, let us see how to expand a plus b power n. So that is, we are writing the expansion of a plus b for any value of n. Here n means n should be a natural number. So we have seen, so in each row for any index what we can write it in terms of its nc0, nc1 like this. If index is n, so coefficients will be of the form nc0, nc1 till where ncn. So the coefficients will be nc0, next nc1, nc2, so on, nc, n minus 1 and ncn. So we have seen in Pascal's triangle, in each row coefficients can be given by nc0, nc1 like that, where n stands for its index. So similarly, we have seen that the powers of a goes on decreases by 1. So initially a power n, next what happens? A power n minus 1, next a power n minus 2, so on. Here what happens? A, here what will get? A power 0. So power of a is go on decreases by 1, and power of b increases by 1. So that is b power 0, b power 1, b square, so on. Here what will get? B power n minus 1, b power n. This is the expansion of a plus b power n, where n is what? N is a natural number. So now see one example. Suppose we have to expand. Consider x plus 2y power 5. So if you compare with the general expansion of a plus b for index n, so what happens here? N value becomes 5. So this is the value of a. A means x. B value becomes 2y. So what we can write? If you use this formula, 5c0, a power n. So a means here x power n value is how much? 5 into b power 0. B value is 2y power 0 plus next 5c1. What will get? A power n minus 1. N minus 1 is 4. Again 2y power 1. Next is 5c2. Simply decrease the power of x by 1 and increase the power of 2y by 1. So 2y square plus 5c3. What will get? X square 2y cube plus 5c4. X 2y power 4 plus 5c5. What will get? X power 0, 2y power 5. So this is the expansion of x plus 2y power 5. You have to compute the value of 5c0, 5c1, 5c2, so on, by using the formula what we have seen. NCR means n factorial by r factorial into n minus r factorial. So one thing you have to remember means n factorial means what? N factorial means n into n minus 1 into n minus 2, so on, 3 to 1. That is multiplying all numbers from 1 to n. One more thing is the value of 0 factorial is 1. So you have to remember these two things to find the values of this 5c0, 5c1, 5c2, so on. Now we are going to prove binomial theorem by using principle of mathematical induction. So we know that the expansion a plus b power n, we will take that as the given statement p of n. P of n means a plus b power n, so that is equals to nc0 a power n plus nc1 a power n minus 1 b, nc2 a power n minus 2 b square, so on. Last term is ncn a power 0 b power n. So we will prove this binomial theorem by using principle of mathematical induction. So we will take this as the given statement p of n. So principle of mathematical induction means we have to prove the statement for n is equals to 1. Then assuming the statement is true for n is equals to k, we have to prove that the statement is true for n is equals to k plus 1. So first we will prove the given statement is true for n is equals to 1. So if I take n is equals to 1, that is p of 1. So what we will get here? A plus b power 1. So a plus b power 1 is a plus b is equals to RHS. Since n is 1, what we can write? 1c0 a power 1 plus 1c1 a power 1 minus 1, that is a power 0 is 1b. So 1c0 value is 1. So 1 into a becomes a. Similarly 1c1 value is 1. So 1 into b becomes b. So we have a plus b is equals to a plus b, which is true. So what we can conclude, the given statement is true for n is equals to 1. So now let us assume the given statement is true for n is equals to k. So p of k becomes, in place of n we are taking k, a plus b power k. So that is equals to, see here what we will get, kc0 a power k plus kc1 a power k minus 1 b, kc2 a power k minus 2 b square, so on. kc k minus 1 a b power k minus 1 plus kck b power k. So we are assuming the statement is true for n is equals to k. So what we have to prove? We have to prove that the given statement is true when n is equals to k plus 1 also. means a plus b power k plus 1. What we should get? In place of n, we should get k plus 1. That is k plus 1 c0, a power k plus 1, k plus 1 c1, a power k plus 1 minus 1 b, so on. So consider the statement p of k plus 1. So p of k plus 1 means that is a plus b power k plus 1. So that is equals to, what we can write? We can write it as a plus b into a plus b power k. So if you multiply these two, what we'll get? We will get a plus b power k plus 1. So that is equals to a plus b into a plus b power k. So we have obtained here a plus b power k means this much. So in place of a plus b power k, I will take this expansion. So that is kc0 a power k plus kc1 a power k minus 1 b plus kc2 a power k minus 2 b square, so on. kc k minus 1 a b power k minus 1 plus kck b power k. So that is equals to, if you simplify, so first I will multiply each term by a. So if I multiply each term by a, so what I will get? See here, kc0 a into a power k. So I can write it as a power k plus 1 plus kc1 a into a power k minus 1. So that is a power k minus 1 plus 1 a power k b. Similarly, kc2 a power k minus 1 b square, so on. Here kc k minus 1 a into a becomes a square b power k minus 1 plus kck a into b power k. Plus, similarly, if I multiply each term by b, so first b into this one, kc0 a power k into b plus kc1 a power k minus 1 b into b becomes b square plus kc2 a power k minus 2 b cube plus so on, this into this. So kc k minus 1 a into b power k minus 1 into b. So I will get b power k minus 1 plus 1, that is b power k plus kck b power k into b. So that is b power k plus 1. So that is equals to, so if you rewrite this expansion, so first I will consider the terms containing a power k plus 1. So I have only one term. So I will write it as kc0 a power k plus 1 plus. Now if you consider the terms containing a power kb. So here we have the term a power kb. Similarly, here also we have the term containing a power kb. So from these two terms we can take a power k into b as common. So it is remaining here kc1 plus kc0 into a power kb. Similarly, next consider the terms containing a power k minus 1 b square. So this is the term c a power k minus 1 b square. Here also we have the term a power k minus 1 b square. So from these two we can take a power k minus 1 b square as common. So coefficients. Here coefficient is kc2, here coefficient is kc1 into a power k minus 1 b square. So continue like this. So what we will get? If you consider the term containing a into b power k, so consider this term. Here we have a into b power k. Here also this term contains a into b power k. So if you take a into b power k as common, so remaining is kck plus kc k minus 1 into a b power k plus, so this is the last time, kck b power k plus 1. So we have rewritten this expansion in this form. So now see that we have seen the value of NCR means what? NCR means n factorial by r factorial into n minus r factorial. If you see the value of kc0 value becomes how much? kc0 means k factorial by 0 factorial into n minus r, that is k minus 0 factorial. So 0 factorial is 1, k minus 0 is k factorial will get cancelled. So the value of kc0 is 1. Suppose if I consider the value of k plus 1 c0, so what is the value of k plus 1 c0? I can write it as n value is k plus 1, r value is 0. So therefore k plus 1 factorial by 0 factorial into k plus 1 minus 0. So k plus 1 factorial. Again k plus 1 factorial will get cancelled. The value is 1. So in place of kc0, since the value is 1, what I can write? I can write it as k plus 1 c0. Similarly, the value of kck value is how much? K factorial by k factorial into k minus k. K minus k is 0 factorial. Again what I will get? K factorial will get cancelled. The value is 1. So that is same as k plus 1 c c k plus 1. So if you find the value of k plus 1, c k plus 1, you will get again 1. So in place of k c k, what I can write? I can write k plus 1 c k plus 1. So one more formula I am going to use, that is kcr plus kcr minus 1. So see here, kcr means what I can write? K factorial by r factorial into k minus r factorial. kcr means k factorial by r factorial into k minus r factorial plus kcr minus 1. kcr minus 1 means again k factorial by r minus 1 factorial into k minus r minus 1. So that is k minus r plus 1 factorial. So here minus of r minus 1, so minus r plus 1. So that is equals to, so see here, we can take k factorial as common, k factorial by r factorial can be written as r into r minus 1 factorial. So from these two I can take r minus 1 factorial as common. Similarly here k minus r plus 1. So this can be written as k minus r plus 1 into k minus r factorial. So again I can take k minus r factorial as common. So if you take these things outside, here what is remaining? 1 divided by here r factorial we have written it as r into r minus 1 factorial. So here remaining is r plus here 1 by, since we have to k factorial outside, r minus 1 factorial is outside. If you take k minus r factorial outside, remaining is k minus r plus 1. So that is equals to k factorial by r minus 1 factorial into k minus r factorial. So simplify this one. So if you simplify, what I will get? So this into this as the LCM, numerator 1 into k minus r plus 1. So that is k minus r plus 1. Here 1 into r, that is plus r, divided by r into k minus r plus 1. So here minus r plus r will get cancelled. So that is equals to, see here, numerator what we are getting? K factorial into k plus 1. So denominator r into r minus 1 factorial. So we can write it as r factorial. Here k minus r factorial into k minus r plus 1. So we can write it as k minus r plus 1 factorial. So that is nothing but what? That is nothing but k plus 1 cr. So if you expand k plus 1 cr, what will get? K plus 1 factorial. So that is nothing but k plus 1 into k factorial becomes k plus 1 factorial. Here r we have. So denominator is r factorial into what we will get? K minus r plus 1 factorial. So that is nothing but k plus 1 minus r factorial. So again we are using this formula kcr plus kcr minus 1. We can write it as k plus 1 cr. By using those formulas, what we can write? So we can write Kc0. Kc0 is same as K plus 1 C0 a power K plus 1 plus we have seen KCR plus KCR minus 1 can be written as K plus 1 CR. So what we can write, adding these two, we can write it as K plus 1 C, R value is here 1, A power K into B plus here again using the same formula. So what we can write, K plus 1 C2 A power K minus 1 B square plus so on. Here KCK plus KC K minus 1, we can write it as K plus 1 CK A into B power K plus we have seen the value of KCK is 1, that is same as K plus 1 CK plus 1 B power K plus 1. So if you see this one, so this is nothing but what? Same expansion, but in place of n what we have? In place of n we have K plus 1. So K plus 1 C0 A power K plus 1 plus K plus 1 C1 A power K plus 1 minus 1, that is A power K B K plus 1 C2 A power K plus 1 minus 2, that is